Now, in this lecture, we will find the radius of the semicircle. In the drawing, we have triangle ABC. Triangle ABC is a right triangle because angle ABC, this angle is a right angle. We also know that side AB of triangle ABC equals to 3 units. Line segment DC, this line segment equals to 1 units. And actually, side AC or triangle ABC, the hypotenuse is tangent to the semicircle at point E. Point E is the point of tangency of tangent AC with this semicircle, and we want to find out the radius of this semicircle. This semicircle is inscribed by triangle ABC, and we also know that side AB is tangent to this semicircle at point B, and we want to find out the radius of this semicircle. So first of all, I will present to you a new rule, rule number 1, or two tangents theorem. Rule number 1 or two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have a circle, suppose that we have this circle, and we also have external point, point P is an external point of this circle. Why point P is an external point? Because point P is not located inside this circle nor on this circle, therefore, but it is located outside the circle, therefore it is defined as an external point of this black circle. So if from the external point P we will draw two tangents to this black circle, so the first tangent will be this tangent, and we will define the touching point between the first tangent and the black circle as point A. So this is the first tangent to this black circle, and from point P we will draw the second tangent to this black circle. And we will define the touching point between the second tangent and the black circle as point B. So actually the length of the first tangent of this tangent is actually PA, and the length of the second tangent of this tangent is actually PB. And according to rule number 1 or 2 tangents theorem, the lengths of two tangents from a common external point, that is to say from point P to a circle, are equal. So the length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 1 or 2 tangents theorem, those lengths are equal to each other. That is to say, the length of the first tangent equals to the length of the second tangent. That is to say, PA equals to PB. So whenever you have an external point of a circle, that is to say point P, and from the external point P you draw two tangents to a circle, like in this drawing you have tangent PA and tangent PB, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay, so that is actually the meaning of rule number 1 or 2 tangents theorem. And we can actually implement rule number 1 in our drawing, because in our drawing we have the external point, point A. Point A is an external point because point A is not located inside this semicircle nor on this semicircle, but it is located outside the semicircle. Therefore, point A is defined as an external point of this semicircle, and from point A, the external point A, we have two tangents to this semicircle. The first tangent is tangent AB, and we also know that the length of AB is 3 units, and the second tangent is tangent AE, and so we have tangent AB is the first tangent, tangent AE is the second tangent, and according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AB equals to AE. But we know that AB equals to 3 units, so AB equals to 3 units. So from this equality, we will derive that AE also equals to 3 units. AE equals to 3 units, so we will write here that the size of AE, or the length of AE, is 3 units. Okay, and we will define the center of this semicircle as point O. Point O is the center of this semicircle, and we will join together points E and O by a straight line. Actually, line segment OE. This line segment is the radius of this semicircle because of the fact that line segment OE starts from the center of this semicircle, that is to say from point O, and ends at point E, that is a point on the semicircle itself. Therefore, line segment OE is the radius of this semicircle. We will define the radius of the semicircle as R. Therefore, OE will be equal to R. It is the radius of this semicircle. And actually, point E is the point of tangency of tangent AC with this semicircle. Okay, write it down. It is point of tangency of tangent AC with this semicircle. We will define the size of EC as X. That is to say, EC equals to X in its size. Likewise, OD is also the radius of this semicircle because of the fact that it starts from point O and ends at point D. It is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, so it equals to R. For the same reason, also BO is the radius of this semicircle. It starts from the center of the semicircle, that is to say from point O and ends at point B. That is a point on the semicircle itself. Therefore, BO is the radius of this semicircle. So, in the next step, I will present to you a new rule number 2, and we will implement rule number 2 in our drawing. So, rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency So I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have a circle, if you have this circle and the center of this circle is at this point, we will define the center of the circle as point O, and we also have a tangent to this black circle. Actually, here tangent AB, this tangent is tangent to the black circle at this point. We'll define it as point M, the touching point between the tangent, and the black circle will be defined as M. Actually, M is also, or point M is the point of tangency point of tangency of tangent AB with this black circle, and we also have radius from the center of the circle from point O to point M. OM is the radius of this black circle. So according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. As you can see from the drawing, this radius OM, is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius that is drawn to the point of tangency. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So whenever you have a radius, like in this drawing, that is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle also equal to 90 degrees. Okay, so that is the meaning of rule number 2. And we'll actually implement rule number 2 in our drawing. In our drawing we have tangent AC is tangent to this semicircle at point E. Point E is the point of tangency of tangent AC with this semicircle, and we have the radius OE that is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. Okay? Because of the fact that the radius OE is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency. Therefore, the tangent AC is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, this is the implementation of rule number 2 in our drawing. And because of the fact that angle OEC, this angle equals to 90 degrees, triangle OEC is a right triangle because it has one angle that equals to 90 degrees. So the green triangle OEC is a right triangle. So we will focus on the right green triangle OEC. Okay? So on the right triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Side OC is the hypotenuse because it is located in front of the right angle. Therefore, OC is the hypotenuse of this green right triangle. So the square of the hypotenuse, it is actually OC square. And according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE square plus EC square. So I'll repeat again. If you focus on the green triangle OEC, then according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. Okay, but what is the value of OC? Here, as you can see from the drawing, the length of OC, it is actually R plus 1, equals to R plus 1. So if OC equals to R plus 1, then OC square will be equal to R plus 1 square. Okay, so OC square equals to R plus 1 square, and it equals to OE square. OE equals to R, so OE square equals to R square plus EC square. EC equals to X according to our definition, so EC square will be equal to X square. So in total we got that R plus 1 square equals to R square plus X square. Here we will open the brackets in this side of equation number 1. R plus 1 square equals to R square plus 1 plus 2R according to the algebraic identity that A plus B square equals to A square plus B square plus 2 times AB. So R plus 1 square equals to R square plus 1 plus 2R, and it equals to R square plus X square. So here we have R square in both sides of equation number 1, so we'll subtract R square from equation number 1, so R square will get cancelled. And what is left after we cancelled R square? What is left, it is actually 1 plus 2R equals to X square. So we found out that according to equation number 1, 1 plus 2R equals to X square. Okay, 1 plus 2R equals to X square. In the next step, we will focus on the right big triangle ABC, and on the small right green triangle OEC. And we will actually prove that those two triangles are similar to each other. Okay, so we will focus on the right big triangle ABC, and the right small green triangle OEC. Okay, I'll repeat again. We'll focus on triangle ABC and on the right green triangle OEC. On those two triangles, we have those two angles that are equal to each other. They are both right angles. So we can write down that angle ABC, this angle in triangle ABC, equals to angle OEC, this angle in triangle OEC, and both angles are right angles, that is to say they are equal to 90 degrees. I will repeat again. Angle ABC in triangle ABC equals to angle OEC in triangle OEC, and they are both equal to 90 degrees, they are right angles. Okay? Then we actually have this angle is a common angle. It belongs to both triangles. It belongs to big triangle, big right triangle, triangle ABC, and this angle, angle C, also belongs to the green right small triangle, this triangle, triangle OEC. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Okay, it is a common angle that belongs to both triangle ABC and triangle OEC. I will repeat again. Angle C equals to angle C is a common angle that belongs to both triangles. And actually those two angles are also equal to each other. So angle BAC, this angle in triangle ABC, is equal to this angle, angle EOC in triangle EOC. And they are equal to each other according to third angle theorem. I repeat again. Angle BAC equals to angle OEC, and they are equal to each other according to third angle theorem. Okay, those two angles are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem, or we can also call it rule number 3 or third angle theorem. So according to third angle theorem, okay, rule number 3 of third angle theorem, according to third angle theorem, if two angles in one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So I will read rule number 3 again. Rule number 3 states that if two angles in one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. Okay, so what is the meaning of third angle theorem? The meaning of third angle theorem is that if you actually have two triangles, we have triangle ABC. This is triangle ABC. And we have also triangle DEF. This is triangle DEF. And two pairs of angles congruent in those two triangles. Here we have the first pair of angles that congruent, angle alpha congruent to angle alpha. This is the first pair of angles that congruent in both triangles. And we have also the second pair of angles that congruent to each other. Angle beta is congruent to angle beta. So we have here two pairs of angles that congruent to each other in both triangles. Then so if this is the situation, then according to rule number 3 of third angle theorem, then the first pair of angles, so those two angles must also congruent. So if this angle is gamma and this angle is defined as theta, then according to rule number 3 of third angle theorem, angle theta must equal to angle gamma. This angle must equal to angle theta. Okay, I will repeat again. Whenever you have two pairs of angles that are congruent to each other, here angle alpha is congruent to angle alpha and angle beta is congruent to angle beta, then the third pair of angles must also congruent. That is to say, angle gamma must be congruent to angle theta, or angle gamma must equal to angle theta. Okay, so we actually prove that the third angle theorem is true. Okay, we'll prove that the third angle theorem is true by using the rule that states that the sum of the angles in any triangle equals to 180 degrees. So, especially in triangle ABC, the sum of its angles must be equal to 180 degrees. That is to say, alpha plus beta plus gamma must be equal to 180 degrees. I will repeat again, according to the rule that the sum of the angles in any triangle equals to 180 80 degrees, then the sum of the angles in triangle ABC must be equal to 180 degrees. That is to say alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles, this angle, must be equal to 180 degrees. So that is to say alpha plus beta plus theta must be equal to 180 degrees. I will repeat again. In triangle DEF, the sum of its angles must be equal to 180 degrees. That is to say alpha plus beta plus theta equals to 180 degrees. Here we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that according to equation number 3, gamma minus theta equals to 0. Here we will add theta to equation number 3, and we will get that angle gamma equals to angle theta. And we proved what we wanted to prove, because we actually proved that if we have two pairs of angles that congruent in two triangles, then the third pair of angles must be also congruent. That is to say, angle theta must be equal to angle gamma, and we indeed proved that angle theta equals to angle gamma. So we actually proved that the third angle theorem is true. Okay, and we will return to our original drawing. We actually proved that three angles of triangle ABC, all three angles of triangle ABC congruent to all three angles of the green right triangle, triangle OEC. Okay? Therefore, we actually proved the triangle ABC, the big right triangle, is similar to triangle OEC, the green right small triangle. So we proved the triangle ABC is similar to triangle OEC, the green right triangle, according to angle similarity rule. I will repeat again. We actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Actually, when you prove that three angles of one triangle congruent to three angles of another triangle, then you prove that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle OEC, the right green triangle, we will conclude that AB over AC equals to OE over OC. repeat again. From the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay, but what is the value of AB? The value of AB is 3 units. It is given us in the question that AB equals to 3 units, so AB equals to 3. What is the value of the hypotenuse AC? The value of the hypotenuse AC is actually 3 plus x. Again, AC equals to 3 plus x. So, actually we found out that AB equals to 3 units, AC equals to 3 over x. And what is the value of OE? The value of OE is actually R, the radius of the semicircle. And what is the value of OC? The value of OC, as you can see from the drawing, it is actually R plus 1. OC equals to R plus 1. So actually we found out that OE equals to R and OC equals to R plus 1, and in total we got that 3 over x, 3 over 3 plus x equals to R over R plus 1. Here we will cross multiply equation number 2, and we will get that 3 times R plus 1 equals to R times 3 plus x. So here we will open the brackets in both sides of equation number 2, and we will get that 3R plus 3 equals to 3R plus R times x. Okay, so we actually open the brackets in this equation number 2, and we got that 3R plus 3 equals to 3R plus Rx. Here we have 3R in both sides of equation number 2, so we subtract 3R from equation number 2, so 3R will get cancelled. And what is left after we cancelled 3R? What is left is actually 3 equals to Rx. Okay, 3 equals to Rx. So here we will divide equation number 2, this equation, by x, and we will get that R equals to 3 over x according to equation number 2. But why it is allowable to divide the equation by x? If x equals to 0, then it is not legal operation, because you can never divide anything by 0. But as you can see from the drawing, x equals to EC, that is to say x is one side of the green triangle, and as a side of a triangle it must be a positive number. A side of a triangle can never be 0. Therefore, we are allowed to divide equation number 2 by x, because x can never be 0. Okay, so we found out that R, the radius of the semicircle equals to 3 over x. But we have already found out in equation number 1 that 1 plus 2r equals to x squared. Okay? So we actually can substitute 2r in this equation number 1, by 3 over x, because r equals to 3 over x according to equation number 2. Okay, so we will do it now. 1 plus 2r, and r equals to 3 over x according to equation number 2, so r is 3 over x equals to x squared. Okay, so here 2 times 3 is 6, so we write it down. We will get that according to equation number 1, 1 plus 2 times 3 is 6, 6 over x equals to x squared. So here we will multiply this equation by x. I will repeat again, it is allowable to multiply the equation by x because x can never be 0. X is the side of a triangle, and the side of a triangle can never be 0. Okay, so we will multiply equation number 1 by x, and we will get that x times 1 is x over x times x is 6, 6 over x times x is 6, and x squared times x is x cubed. So here we will subtract from equation number 1 x, and we will get that x cubed minus x equals to 6. Here we will subtract 6 from equation number 1, and we will get that x cubed minus x minus 6 equals to 0. Here we will add 0 to this equation. What is 0? 0 is actually 0 equals to minus 2x plus 2x minus 2x plus 2x is 0. So it is allowable to add 0 to any equation. So we will add 0 to this equation. That is to say, we will add, it will be x squared minus 2x squared plus 2x squared is 0, so it is allowable to add 0 to the equation. Minus x minus 6 equals to 0. Okay, so we added 0, that is minus 2x plus 2x, to this equation, and we got this expression. So here we will substitute minus x, actually minus x equals to minus 4x plus 3x. I will repeat again, minus x equals to minus 4x plus 3x. So we will substitute minus x in equation number 1, this minus x, by minus 4x plus 3x. Okay, and we will get that according to equation number 1, x cubed minus 2x squared plus 2x squared, and instead of minus x we write down minus 4x plus 3x, that equals to minus x, minus 4x plus 3x minus 6 equals to 0. Okay, so we substituted minus x by minus 4x plus 3x, and we got this expression number 1. So here we will divide equation number 1 to 3 parts, and from each part we will take a common factor. So this will be the first part, this will be the second part, and this will be the third part. So we will take a common factor from each part. Okay, so the first part is x cubed minus 2x squared this is the first part. We will take a common factor from this expression. The common factor that we will take will be x squared. So what is left inside the brackets after we took a common factor x squared? What is left from x cubed? What is left? It is actually x. And what is left from minus 2x squared after we took x squared as a common factor? What is left? It is actually minus 2. So we actually found out that x cubed minus 2x squared equals to x squared times x minus 2. We will do the same process on the second expression. The second expression is actually 2x squared minus 4x. So we will take a common factor from 2x squared minus 4x. The common factor will be 2x. So what is left from 2x squared after we took a common factor 2x? What is left? It is actually x. And what is left from minus 4x after we took a common factor 2x? From it, what is left? It is actually minus 2. So we actually found out that 2x squared minus 4x equals to 2x times x minus 2. So we'll do the same process on the third expression. The third expression is 3x minus 6. Minus 6, and the common factor that we will take from 3x minus 6 will be 3. So what is left from 3x after we took a common factor of 3 from it? What is left? It is actually x. And what is left from minus 6 after we took a common factor of 3 from it? What is left? It is actually minus 2. So in total we found out that 3x minus 6 equals to 3 times x minus 2. So here we can substitute those three expressions by those three expressions because they are equal to each other, and those three expressions in total equal to 0. So here we will substitute this expression by this expression, we will substitute this expression by this expression, and we will substitute this expression by this expression, and we will get that x squared times x minus 2 plus 2x times x minus 2 plus 3 times x minus 2 all equals to 0 according to this equation that it equals to 0. So here we will take a common factor of x minus 2 out of this expression, and we will get that x minus 2 is a common factor. So what is left from x squared times x minus 2 after we took a common factor of x minus 2? What is left? It is actually x squared. And what is left from 2x times x minus 2 after we took a common factor of x minus 2? What is left? It is actually 2x. And what is left from the third expression, 3 times x minus 2, after we took from it x minus 2 as a common factor? What is left? It is actually 3, and all equals to 0. So we found out that x minus 2 times x squared plus 2x plus 3 equals to 0. Here we will have two possible solutions to this equation, equation number 1. Either x minus 2 will be equal to 0, or x squared plus 2x plus 3 will be equal to 0. Because if x minus 2 equals to 0, then 0 times anything equals to 0, and if x squared plus 2x plus 3 will be equal to 0, then 0 times anything will be equal to 0, so 0 equals to 0. So we have here two possible solutions. The first possible solution is that x minus 2 equals to 0, and the second possible solution is that x squared plus 2x plus 3 equals to 0. I'll repeat again. We have two possible solutions to equation number 1. Either x minus 2 equals to 0, or x squared plus 2x plus 3 equals to 0. So we will focus on the second solution. The second solution, x squared plus 2x plus 3 equals to 0, it is a quadratic equation. And the general formula for a quadratic equation is actually ax squared plus bx plus c equals to 0. That is the general formula for a quadratic equation. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x by using a special formula for x. The special formula is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2 times a. So we will use this formula in order to find out the value of x when a, b, and c are the coefficients of this quadratic equation. So in our specific quadratic equation, x squared plus 2x plus 3 equals to 0, the coefficients of this specific quadratic equation are as follows. Here a equals to 1, the coefficient b equals to 2, and the coefficient c of this quadratic equation equals to 3. So the only thing that is left to do is to put this data inside this equation for x in order to find out the value of x. So we will do it now. We will get that x according to the special formula for x will be equal to minus b equals to 2, so minus b is minus 2 plus minus square root of b square, b equals to 2, so b square is 2 square, 2 square is 4, minus 4 times a is 1, so it is 4 times 1, times c is 3. So it is 4 times 1 times 3 over 2 times a, 2 times a is 1, so 2 times 1 is 2. So in total we got this expression. So actually x equals to minus 2 plus minus square root of 4 minus 4 times 1 times 3 minus 4 times 1 times 3 is minus 12 over 2. Okay, so we actually found out that x, the variable that we are looking for, equals to minus 2 plus minus 4 minus 12 is minus 8. So because of the fact that a negative number doesn't have a root, that is to say, this quadratic equation doesn't have a solution. Okay, because of the fact that a negative number 8 is a negative number, and a negative number doesn't have a root, therefore there is no solution to this quadratic equation, so this possibility is cancelled. It is not the solution for our equation number 1, and the only solution that is left is that x minus 2 equals to 0. Okay, the only solution that is left is that x minus 2 equals to 0, and if x minus 2 equals to 0, then x will be equal to 2. So we found out that x equals to 2. And we have already found out that according to equation number 2, the radius of the semicircle equals to 3 over x. So we can substitute x in equation number 2 by 2 because we found out that x equals to 2. Okay, so we will get that the radius of the semicircle equals to 3 over x, and x equals to 2. So the radius of the semicircle equals to 3 over 2 units. Or we can represent it also that the radius of the semicircle equals to 1.5 units. Okay, so I actually found out that the radius of the semicircle equals to either 3 over 2 units or it equals to 1.5 units. I will repeat again. We found out that the radius of this semicircle R equals to either 3 over 2 units or it equals to 1.5 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle. We know that triangle ABC is a right triangle. Side AB equals to 3 units, angle ABC equals to 90 degrees, line segment DC equals to 1 unit, and the semicircle is described by the triangle ABC, and we want to find out the radius of this semicircle. So, in the first step, I presented to you rule number 1, according to rule number 1 or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this black circle and we have the external point P, and from this external point P we will draw two tangents to this black circle. The first tangent is tangent PA, the second tangent is tangent PB. Then according to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So the length of two tangents, tangent PA and tangent PB, from a common external point, that is to say from point P to a circle, to the black circle, are equal. That is to say, the length of the first tangent, this first tangent is PA, the length of the second tangent is PB, and according to two tangent theorem, those lengths are equal to each other. That is to say, PA equals to PB. So whenever you have a common external point of a circle and you draw two tangents to that circle, then the length of those two tangents will be equal to each other. In this case, PA will be equal to PB, and we actually implemented rule number 1 or two tangent theorem in our circle. We have in our drawing the point A. The point A is an external point of this semicircle, and from point A we have two tangents to this semicircle. The first tangent is tangent AB, it equals to 3 units in its size, and the second tangent is tangent AE. So according to rule number 1, whenever we have two tangents from an external point to a circle, to that circle, from point A to that circle, then the lengths of those two tangents are equal to each other. That is to say, AB equals to AE according to two tangents theorem. But we know that AB equals to 3 units. It is given us the question that AB equals to 3 units. So from this equality we will derive that AE also equals to 3 units. So we found out that AE equals to 3 units. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this black circle and the center of this black circle is at point O, and we also have tangent AB. Tangent AB is tangent to this black circle at point M. Point M is the point of tangency of tangent AB with this black circle. So according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its points of tangency. So this radius OM, is drawn to the point of tangency, that is to say it is drawn to point M. Therefore, the tangent AB is perpendicular to this radius according to rule number 2. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, like in this drawing, this radius OM, is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency, then the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so we actually implemented rule number 2 in our drawing, because in our drawing we have AC, tangent AC or side AC or tangent AC is tangent to the semicircle at point E. Point E is the point of tangency, and we have the radius OE. The radius OE is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that angle OEC equals to 90 degrees, then the green triangle is the right triangle. Triangle OEC is the right triangle. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus AC square. OC is the hypotenuse. OC is the hypotenuse, so the square of the hypotenuse is OC square equals to the sum of the squares of the perpendiculars equals to OE square plus EC square. Okay, OC square equals to OE square plus EC square. OC, from the drawing you can see that OC equals to R plus 1, so OC square will be equal to R plus 1 square. OE equals to R, so OE square will be equal to R square. And EC equals to X according to our definition, so EC square will be equal to X square. So in total we got that R plus 1 square equals to R square plus X square. We open the bracket in this side of equation number 1 and we got that R plus 1 square equals to R square plus 1 plus 1. And it equals to R square plus X square. Here we have R square in both sides of equation number 1, so R square will get cancelled. And what is left after we cancel R square? What is left? It is actually 1 plus 2R equals to X square. So according to equation number 1, 1 plus 2R equals to X square. Okay, then we focus on the right green triangle, triangle ABC, and on the green small right triangle, triangle EOC. And we prove that those two triangles are similar to each other. First of all, we have those two angles that are equal to each other. They are both right angles. That is to say, angle ABC in triangle ABC equals to angle OEC in triangle OEC. And they are both equal to 90 degrees. And we also have this angle is the common angle, it belongs to both triangles. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. And we actually proved that those two angles are equal to each other according to third angle theorem. So actually angle BAC in triangle ABC equals to angle OEC in triangle OEC according to third angle theorem. So what is third angle theorem? The third angle theorem is that, or rule number 3, if two angles in one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 of third angle theorem? The meaning of rule number 3 of third angle theorem is that if we have two triangles, this triangle ABC and triangle DEF, and in those two triangles we have two pairs of angles that congruent. This is the first pair of angles that congruent, they are both equal to alpha, and we have also the second pair of angles that congruent, they are both equal to beta. So if this is the situation, then according to third angle theorem, the third pair of angles must be also congruent, that is to say angle gamma must be equal also to angle theta. So whenever we have two pairs of angles that congruent in two triangles, then the third pair of angles must be also congruent. That is to say, angle gamma must equal to angle theta. So we proved that the third angle theorem is true by using the rule that states that the sum of the angles in any triangle equals to 180 degrees. That is to say, especially in triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Again, in triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. Okay, this is equation number 2. So we subtracted equation number 1 from equation number 2, and we got that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees. Minus 180 degrees is 0. So we found out that gamma minus theta equals to 0. We added to equation number 3 theta, and we found out that angle gamma equals to angle theta. So we actually proved that if we have two triangles with two pairs of angles then that congruent to each other, then the first pair of angles must also congruent. That is to say, angle gamma must be equal also to angle theta. So we actually proved that the third angle theorem is true. Then we return to our original drawing, and in our original drawing we proved that all three angles of triangle ABC congruent to all three angles of the green right triangle, triangle OEC. Therefore, we proved that triangle ABC is similar to triangle OEC according to angle similarity rule. Okay, and from the fact that triangle ABC congruent to triangle OEC, we can conclude that AB over AC in triangle ABC equals to OE over OC. Again, AB over AC in triangle ABC equals to OE over OC in triangle OEC. But what is AB? AB equals to 3 units. And AC equals to 3 over X. So AB equals to 3 units and AC equals to 3 over X. And what is OE? OE equals to R. And OC equals to R plus 1. Okay, OE equals to R and OC equals to R plus 1. So in total we got that 3 over 3 plus X equals to R over R plus 1. Here we cross multiply the equation number 2 and we got that 3 times R plus 1 equals to R times 3 plus X. We open the brackets in equation number 2 and we got that 3R plus 3 equals to 3R plus RX. Here we have 3R on both sides of equation number 2, so we can subtract 3R from equation number 2 and we will get that 3R is cancelled. So what is left after we cancel 3R? What is left? It is actually 3 equals to R times X. We divided the equation number 2 by X and we got that the radius of the semicircle equals to 3 over X. And we also have, so why it is allowable to divide the equation by X? Because X can never be 0. X is the side of a triangle and it must be a positive number, it can never be 0. Therefore it is allowable to divide the equation number 2 by X. So we got that R equals to 3 over X from one side, but we have already found out that according to equation number 1, 1 plus 2R equals to X squared. So we can substitute 2R in equation number 1 by 3 plus X, because R equals to 3 plus X according to equation number 2. So we substituted R by 3 over X and we got that 1 plus 2 R is 3 over X equals to X squared. 2 times 3 is 6. So we got that 1 plus 6 over X equals to X squared. Here we multiplied the equation number 1 by X and we got that X plus 6 equals to X cubed. We subtracted X from equation number 1 and we got that X cubed minus X equals to 6. Here we subtracted 6 from equation number 1 and we got that X cubed minus X minus 6 equals to 0. Here we added 0 to equation number 1. It is allowable to add 0 to any equation. 0, it is actually minus 2x squared plus 2x squared is 0, so we actually added 0 to equation number 1. So we got that x cubed minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Okay, we added this expression that equals to 0 to equation number 1. Then we substituted minus x in equation number 1 by minus 4x plus 3x. Minus 4x plus 3x is minus x, so we can substitute minus x by minus 4x plus 3x. So we did it and we got this expression, and here we divided the equation number 1 to 3 parts, and we took a common factor from each part. Okay, so the first part is x cubed minus 2x squared. The first part of equation number 1 is x cubed minus 2x squared. The common factor that we took from this expression is x squared. And what is left from x cubed after we took x squared as a common factor? What is left? It is actually x. And what is left from 2x squared? What is left from minus 2x squared after we took x squared as a common factor? What is left? It is actually minus 2. So in total we got that x cubed minus 2x squared equals to x squared times x minus 2. Then we took a common factor from expression number 2. Expression number 2 is 2x squared minus 4x. And the common factor that we took from this expression is 2x. So what is left from 2x squared after we took 2x as a common factor of this expression? What is left? It is actually x. And what is left from minus 4x after we took 2x as a common factor? What is left? It is actually minus 2. So in total we got that 2x squared minus 4x equals to 2x times x minus 2. Then the third expression, it is actually 3x minus 6, and the common factor that we took from this expression is 3. So what is left from 3x after we took a common factor of 3 from it? What is left? It is actually x. And what is left from minus 6 after we took a common factor of 3 of it from it? What is left? It is actually minus 2. So in total we got that 3x minus 6 equals to 3 times x minus 2. So here we can substitute x cubed minus 2x squared by x squared times x minus 2. They are equal to each other. We can substitute 2x cubed, 2x squared minus 4x by 2x times x minus 2, and we can substitute 3x minus 6 by 3x 3 times x minus 2 from equation number 1, and we know that the sum of those three expressions equals to 0. So we substituted those three expressions by those three expressions, and we got this expression, and the sum of those three expressions equals to 0, as I already showed to you. And from this expression, equation number 1, we took a common factor x minus 2. Okay, we took a common factor of x minus 2 from this expression. So x minus 2 is a common factor. So what is left from x squared times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually x squared. And what is left from 2x times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually 2x. And what is left from 3 times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually 3. So in total we got that x minus 2 times x squared plus 2x plus 3 equals to 0. Here we have two solutions that are possible. The first solution is that x minus 2 equals to 0, and the second solution is that this expression x squared plus 2x plus 3 equals to 0. Okay? And here we related to the second solution. The second solution is a quadratic equation. X squared plus 2x plus 3 equals to 0 is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following special formula for x. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So in order to find out the value of x, we will put the data inside this equation in order to find out the value of x. So in our specific quadratic equation, x squared plus 2x plus 3 equals to 0, a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this equation in order to find out the value of x. Here x equals to minus b is 2, so minus b is minus 2, plus minus b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, minus 4 times a is 1, minus 4 times 1, c is 3, so it is minus 4 times 1 times 3 over 2 times a is 1, so 2 times 1 is 2, and we got that x equals to minus 2 square root of 4, minus 4 times 1 times 3 is minus 12, so we got that x equals to minus 2 plus minus square root of 4 minus 12 over 2. So x equals to minus 2 plus minus 4 minus 12 is minus 8 over 2. And because of the fact that minus 8 is a negative number, and a negative number doesn't have a root. Therefore, there is no solution to this quadratic equation because a negative number doesn't have a root. So there is no solution to this quadratic equation, so this possibility is cancelled, and we left only with the possibility that x minus 2 equals to 0. And if x minus 2 equals to 0, then x will be equal to 2. X minus 2 equals to 0, so x equals to 2. And according to equation number 2, we have already found out that the radius of the semicircle equals to 3 over x. So we can substitute x by 2 because x equals to 2. So we substitute the x by 2 and we got that r equals to 3 over 2 because x equals to 2, so r equals to 3 over x, x is 2, so r equals to 3 over 2 units, or we can present it as r equals to 1.5 units. So I'll repeat again. The radius of this semicircle equals to either 3 over 2 units or it equals to 1.5 units. Okay, thank you very much.